Boys and girls, this is Mr. Manise here again with another video, and in this video I'm going to walk you through how to solve each of the problems on the probability test review. My disclaimer as always, I need you guys to actually work through the problems on your own first and then come to the video and see where you might have made any mistakes or have any misunderstandings. So my Clemson reference, as always, in light of our recent M&M and Skittles activity, I got some orange M&Ms up here, and for some reason this guy in the middle, they decided not to stamp him with an M. So I actually had a student that said they have never tried an M&M or a Skittle. Hard for me to wrap my arms around that. M&Ms are lovely. They are wonderful. Okay. So let's go ahead and jump in here. Day 8 test review. I need you guys to go ahead and get out your calculator so we can convert some of these decimals to percentages. And on the test tomorrow, guys, about 2/3 of the test is multiple choice. Some of the answers will be left in forms of decimals, some in fractions, some in percents, okay? Remember, with probability, you can leave it as any 3 of those, okay? All right, so number 1. Catherine is playing a card game with a standard 52 card deck, and you guys will have access to your little card sheet tomorrow on the test, showing you all the 52 cards. You don't have to memorize any of that kind of stuff. She wants her first draw to be a spade or a face card. Okay, here's the graphic organizer that we're talking about. So I put this together. I wanted you guys to be able to know, what do you do when you see the word and? What do you do when you see the word or? When you see the word and, you're going to multiply your probabilities, and then it's just a matter of whether or not you see the words with replacement, without replacement. If it's without replacement, you're not putting the card back. You're not putting the marble back. Your denominator is going to decrease by 1 each time if you're pulling out one individual thing. If you see the word or, if you're in or land, then that means you're going to add the probabilities. And then it's just a matter of whether or not you have any overlap. Can I be a heart and a jack at the same time? Yes, the jack of hearts. I have to subtract out that jack of hearts because that's the overlap. Make sure you guys have a good handle on this graphic organizer before you walk into the test, okay? Probability, guys, is all about trigger words, important phrases, key words. She wants to draw a spade or, ding, 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 there's the most important word in the whole problem, spade or a face card. So as we saw in our graphic organizer, when I see the word or, I'm going to add my probabilities together. Okay, what is the probability that she draws a spade or a face card on her first draw? Okay, when I see the word or, guys, I'm only drawing one thing. I'm drawing one card. It's either this or this, this or this. Okay. When you see the word and, I'm drawing multiple things. I'm going to draw a green marble, and then a blue marble, and then a yellow marble. You're drawing more than one thing. Okay, when you see the word or, it's one thing. Okay, so what we're going to do, we're going to add our probabilities. What's the probability of drawing a spade? There are 13 spades in the deck. There are 4 suits. There are 13 hearts, 13 spades, 13 clubs, 13 diamonds. 13 out of 52. Okay, all right, so we've got 13 out of 52 spades. Okay, and then we've got our face cards. How many face cards are in the deck? So once again, you guys are just going to have to look at your card sheet if you're not familiar with cards. A face card, guess what? It has a face on it. Okay, those are going to be my jacks, my queens, and my kings. Some of you guys on the quiz, on the probability quiz, you added an ace in there. Ace is not a face card, doesn't have a face on it. Okay, so I've got 4 jacks, 4 queens, and 4 kings. Okay, so I've got 12 face cards. Okay, so I'm going to add those together. Now I've got to stop and ask myself, is this inclusive or exclusive? Can I have a spade and a face at the same time? Okay, so you're going to need to look at your card sheet. I'll pull this out here real quick just so you guys can see it. Can I be a spade and a face card at the same time? Yes, and that's going to be all 3 of my face cards that are spades. The jack of spades, the queen of spades, the king of spades are both a spade and a face card at the same time. So we have to subtract those out so that we don't double count them. That's the whole point of subtracting the overlap. Okay, so I have to subtract out those 3 face cards that are also spades. Okay, since I have a common denominator, I can just do 13 plus 12 minus 3, and that comes out to be 22 over 52. So on the test tomorrow, if all the answers are in the form of a fraction and yours don't match, that may be a red flag. Hey, wait a minute, maybe I need to simplify this, okay? Let the calculator do the work. 22 divided by 52, get some decimal, okay? The multiple choice answers might be in this form, in decimals, and that's fine. If I want to convert it to a fraction, I press the math button right here where my finger is, math. You see option 1 is fraction, and I press enter twice. 1, 2, bam. And it simplifies my fraction for me. 11 out of 26. Now, obviously, most of you guys could look at this and just divide the top and bottom by 2. However, some of you guys that aren't comfortable with fractions and numbers and all that kind of stuff, let the calculator do the work so you don't make a mistake. All right, 11 out of 26 chance. Okay, number 2, letters to the word mathematics are placed in a bag. What is the probability of pulling the letter M, then without replacement, pulling a vowel? Okay, so here are the important words in here. We've got without replacement. Okay, do you see the word and? What is the probability of pulling the letter M and without replacement? I don't see and. Do you see or? No, I don't see the word or. Well, where is it? Okay, remember, like I said on number 1, when you're pulling multiple things, that's the and. Okay, the word and is in there. It's right here. They just didn't put it in this particular problem. What is the probability of pulling an M out of the bag and then pulling a vowel? I'm pulling multiple things, okay? So the and is embedded in the problem. What do I do when I see the word and? I multiply, okay? So what are the chances of pulling the letter M? How many M's do I have? I have 2 M's, okay? How many total letters do I have? You're just going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 letters, okay? So there's 2 out of 11 chance that I'm pulling M. The and is in there, so I'm going to multiply, okay? Without replacement, what are the chances of pulling a vowel? Okay, well, how many vowels are there? 1, 2, 3, 4. There are 4 vowels, but it says without replacement. So I'm pulling the M, I'm physically pulling the M out of the bag, and I don't put it back in the bag. So I don't have 11 letters anymore. I've already pulled out one of these M's. Okay, so now I'll only have 10 letters left in the bag. Okay, let the calculator do the work. 2 divided by 11 times 4 divided by 10. Oops, sorry, I can't see that. All right, fine. Maybe that's the answer on the test. Or math, enter, enter. That comes out to be 4 out of 55. By the way, if the answer's tomorrow in terms of percentages, when you do 2 divided by 11 times 4 divided by 10, that's a decimal. If I want the percent, I just move the decimal 2 spots or I multiply by 100%. This would be the same thing as 7.3%. Okay. All right. Moving along. Number 3. A baseball player got a hit 27 times out of his last 78 at-bats. If this player comes up to bat 250 times this season, about how many, guys, how many? Students sometimes get confused between how many and probability. Probability, when you see this word, that's a fraction, that's a decimal, that's a percent, something divided by the total, okay? Favorable outcomes over total outcomes. When you see the word how many, this is a hard number. This is a physical number. How many people, how many hits, how many dollars, okay? So basically what I'm going to do is I'm going to take this ratio. This person is got 27 hits out of 78 at-bats. You don't have to do this. I'm just doing this for illustration purposes. 27 divided by 78 times 100. So they're getting a hit about 34% of the time. Or in baseball terms, they're batting .346. That's really good, man. You hit a baseball 1 out of 3 times, you're going to make millions of dollars in the major league. Okay, so they're hitting the ball. They're making a hit about a third of the time. So doesn't it make sense? I'm trying to figure out if they come up to 250 times, they come up to the plate, how many times will we expect them to get a hit? Doesn't it make sense that I would just take a third or 34% of this number? Why, yes, Mr. Mooney. So I'm going to take this fraction, this probability, decimal, percent, fraction, and I'm simply going to multiply that times the number of times I come up to bat. So 27 divided by 78 times 250, that gives me, oops, 250, sorry. 27 divided by 78 times 250. Okay, we would expect them to get about 87 hits, okay, approximately 87 hits. So I'm going to put the little squiggly lines, about 87 hits. Notice my final answer, guys, is not in the form of a probability. It's a hard number. How many? Okay. All right. Number 4, when rolling 2 standard number cubes, let me grab my 2 dice over here. A number cube just means a dice, numbers 1 through 6. At a casino, we're going to the casino. What is the probability? Okay, not number. What's the probability of getting the following? Okay, a product of 20. Okay, so product means multiply. Okay, how can I roll 2 of these dice and get 2 numbers that when I multiply them together get a 20? Well, I can't roll a 1. 1 times 6, that didn't get me 20. I can't roll a 2 because that would need to be 2 and 10. I can't roll a 3. Okay, 3 times 8 is 18. That doesn't do anything for me. I can roll a 4 and I can roll a 5. Okay, that's one combination. So I could roll a 4, 5. However, I could also roll a 5 and a 4. And you might say, well, those are the same thing. No, it's not, because one of them's on the blue. I got blue 4, red 5, and then blue 5, red 4. Those are 2 distinct different combinations. So I can roll a 4 and a 5 and a 5 and a 4. Okay, those are the only 2 ways that I can multiply and get a product of 20. So it's 2 combinations. I have 2 combinations out of a total of how many? And a lot of students will say 12 because they'll add the 6 and the 6. Nope. If you guys remember the problems that we worked on where we had 4 pants, 3 shirts, and say 6 hats, how many different combinations of clothing do I have? What do we do with these numbers? We multiply it. 4 times 3 times 6. That gives me the total combinations. Well, I've got 6 possible outcomes on the blue die, 6 possible outcomes on the red. So I'm going to multiply these together. 6 times 6 is 36. So when you roll 2 dice, guys, you have 36 different possible outcomes. Okay. So for a product of 20, that's 2 out of 36. That simply reduces to 1 out of 18. Okay. All right. On these 2 dice. 1 die, 2 dice. How can I get a sum of 5? That means they have to add together to give me a 5. Well, I can roll a 1 and a 4. That's one combination. I can roll a 4 and a 1. That's another combination. I can roll a 2 and a 3. I can also roll a 3 and a 2. Okay, and that's it. There's no other way to get a sum of 5. Okay, that's 4 different combinations. 4 combinations, again, out of a total of how many different possible combinations? I still have 36 possible combinations. So 4 over 36 reduces to 1 over 9. Okay, how can I get a sum of 13? Well, if I add 6 and 6, oh, wait a minute. 6 plus 6, that's only 12. How do I get a sum of 13? You can't. 0% chance you can get a 13. Can't happen. Okay, now here's where we start to deviate a little bit. An even sum given. Given, guys, there's a very, very important word. Up here, we're just asking out of all the possible combinations, how can I get a product of 20? Okay, well, now we have a certain condition, given that 1 cubed lands on a 2. So I don't have 36 combinations anymore because I'm assuming under the condition that one of these guys is a 2. Let's say the blue one is a 2. If this guy is a 2, one of them lands on a 2, either the blue one or the red one. Let's just say for a second it lands on the blue one is a 2. There are only 6 combinations. I can roll a 2 and a 1. I can roll a 2 and a 2. I can roll a 2 and a 3. 2 and a 4, etc., etc. 2 and a 5, and I can roll a 2 and a 6. Okay, those are my only different combinations if I assume this one die is a 2. Out of these combinations, what are the chances that the sum is even? Well, 2 and 2 is even, 2 and 4 is even, 2 and 6 is even. So out of these 6 combinations, if we assume one of these guys is a 2, 3 out of the 6 combinations give me an even sum, which is 1/2. Doesn't that make sense? If I assume I roll a 2, the chances this other guy is going to give me an even is going to be 1 out of 2. Half the times it'll be even, half the times it'll be odd. As soon as I say that, I roll like 3 6s in a row. Okay, here's another 6. Theoretically, it should be 1 out of 2. Experimentally, it might be something different. Okay, same type of question here on E. given under the condition that it lands on a 3. All right, so let's say this time the red one lands on a 3. Okay, what are my possible outcomes? All right, I can have a 3 and a 1, 3 and a 2, 3 and a 3, 3 and a 4, 3 and a 5, 3 and a 6, just like we had before. Okay, 6 combinations. How many of these will give me a sum of 8? 4, 5, 6, 7, 8. That's the only one, guys. That's the only combination that will give me a sum of 8. So this is just going to be 1 out of 6 combinations. Okay. If I assume that guy's a 3, I got a 1 out of 6 chance that this is going to be a 5. But that will give me a sum of 8. Okay. Okay, let's move along. Moving away from the world of dice. I love dice. I love cards. Man, I love it. Can't get enough of it. All right. In the ball bin in the gym contains 6 soccer balls, 12 basketballs, 10 kickballs. If Coach Meyer selects 2 of these out of the bin randomly and doesn't replace without replacement, what is the probability that she selects 2 basketballs? Okay. Do you see the word and in here? Do you see the word and? No. Do you see the word or? No. But remember what I said at the beginning of this video. If you are pulling multiple things, that has to be the and. And that's what we're doing here. We are pulling two balls out of the bin, right? So I'm pulling one ball and then another ball, okay? So, but in this case, we're pulling 2 basketballs back to back, okay? And also, if you can't remember the and, if you don't see the word and or, if you see doesn't replace without replacement, well, here we go. Graphic organizer, without replacement. We are in the land of and, okay? Now, I will say on the test, guys, you will see the words and or. We're not going to make you hunt for those trigger words, so it will be pretty straightforward on the test. But if you don't see them, you can still figure out whether or not you multiply or add your probabilities. Okay, so what are the chances that the first one is a basketball? Okay, we've got 12 basketballs out of how many total? I've got 20, 30. I got 12 basketballs out of 30. Okay, I don't put it back. Okay, here's my bin of basketballs and stuff. I'm going to pull a basketball out of the bin. I don't put it back. Okay, so the next time I don't have 30 basketballs anymore. Okay, but also I'm trying to get 2 basketballs back to back. So if I pull this basketball out of the bin, I don't have 12 basketballs in the bin anymore. I only have 11 basketballs because one's sitting over here on the side, and I don't have 30 balls in the bin anymore because one of the balls is sitting over here. So I only have 29 balls left. When you see without replacement or doesn't replace, your denominator is going to decrease. Now, in this case, the numerator actually also decreases as well. That's because we're pulling something back to back. I'm pulling 2 male fish out of the aquarium. I'm pulling 2 basketballs. If this had problem said, what are the chances of pulling a basketball and then a kickball, then it'd be 12 over here, and then it would be 10 on the next one, okay? So just keep that in mind. All right, so I'm going to let my calculator do the work. 12 over 30 times 11 over 29, math, frac. And I get 22 out of 145. Okay. Small camera, you can do it. There you go. All right, number 6. At a shoe store yesterday, 62% of customers bought shoes, 38 bought accessories, 24 bought both shoes and accessories. Okay, shoes and accessories, guys. This is your both. Okay, if you remember this was day 5, conditional probability. If you remember, the conditional probability is going to be equal to the probability of both over the probability of the given. Okay, and go back and look in your notes if you can't remember that. Okay. All right, so now we've got our probability conditional notation. Remember, guys, whatever comes second, whatever comes after the bar, that is your given. So physically, I want you guys to physically write that word down. Write it on your test. Okay, given. Okay, what are the probabilities? What are the chances that somebody bought shoes under the condition that they also bought accessories? So if we assume they bought accessories and they're buying shoes, is that not the both? They are buying both shoes and accessories. Okay. So the given goes on the bottom. Now, me personally, Mr. Manise, I always like to put the given on the bottom. The accessories, 38% bought accessories. So the 0.38 goes on the bottom. What goes on the top? Okay, it's not shoes. Okay, if you had made that mistake, if you put the 62 on top, watch what happens, guys. 0.62 divided by 0.38, that's a number greater than 1 times 100%. Guys, you cannot have a number greater than 100% in probability. Can't happen, okay? So that's a red flag. Oh, wait a minute, I did something wrong. I want both. Remember, both goes on top. That's the 24% number, or 0.24. Okay, the chances they have both under the condition that they bought accessories. Type that in, 0.24 divided by 0.38, and that gives me 0.24 divided by 0.38, and that gives me 0.63. If I converted that to a fraction, I would just move the decimal 2 places, and I would just round this to say 63.2 if we wanted to round to the nearest tenth, or 63% if you round it to the nearest whole number. You just have to pay attention to the answers on the test tomorrow, what form they're in. All right, letter B, what are the chances they bought accessories under the condition that they already have shoes? All right, so the given goes on the bottom, so shoes goes on the bottom. All right, so there's the shoes, 0.62 on the bottom. And what goes on the top? It's not the 38, guys. It is not the 38. Because remember, these people are buying both. Okay, they're buying both accessories and they have shoes. So remember, the both number goes on top, 0.24. Okay, divided by 0.62. That gives me 0.38 times 100%, 38.7%. Okay, moving along, number 7, at a local carnival, there is a spinner with numbers 1 through 20 on it. We're assuming this is a fair spinner, they're all equal. What is the probability that you roll a number less than 10, bam, or, there it is, guys, circle it, or a multiple of 5? Come on, camera, you can do it. I have faith in you. There you go. Okay, what is the probability that we roll a number less than 10? Guys, you got to pay attention to these words. Reading comprehension. Read these problems 2 times, guys. Don't just read it once and assume you understand. Read it twice. Underline less than 10. So your brain says, okay, it's not 10 or less, it's less than 10. How many numbers are less than 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9 numbers are less than 10. I've got 20 different sections or regions, so I've got 9 out of 20 regions are less than 10. All right, that's less than 10, or a multiple of 5. Okay, what are my multiples of 5? That just means it's divisible by 5. 5, 10, 15, 20. Those are my numbers that are divisible by 5. Now I got 4 of those. Okay, plus 4. Why am I adding? Because I see the word or. Now, do I need to subtract any overlap? Is this inclusive? Can I be less than 10 and a multiple of 5? In other words, do any of these numbers show up over here? And the answer is yes. Okay, one of these. The 5 is less than 10 and it's also a multiple of 5. So I have to subtract out that guy. I can't count it over here and count the 5 over here. I'm double counting. So I have to subtract out that 1 out of 20. I have to subtract out the 5. 9 plus 4 is 13 minus 1 is 12 out of 20. And let your calculator do the work. For sake of time, I'm not going to use my calculator on all of these, so I'll let you guys do that on your own. That comes out to be 3/5. Okay, number 8. So we've got our chart. What kind of chart is this? This is a two-way frequency chart table because I have stuff over here in the rows. I have stuff over here in the columns. Okay, so here's where we got our joint frequencies and our marginal frequencies. Okay, all right. So these are not hard numbers, guys. These are actually decimals. Okay, this is 0.25, 0.43. So this is called a relative frequency table. These are all probabilities. These are all fractions, decimals, percentages. In this case, these are all decimals. Okay. So then we've got to start answering questions. All right. With all these conditional problems, guys, the two-way frequencies, the given is the key word, guys. And sometimes you will see the word given in the problem. Sometimes you'll just see it in the notation here, okay? So down here we have the words, up here we have the notation. But remember, guys, whatever comes second is the given, okay? The female comes after the bar. That's the given, okay? All right, now listen to me very carefully. Listen to me. Listen to me. press go backwards 10 seconds on YouTube if you're watching this after you listen to me say this. Guys, whatever the given is, whatever comes after the word given in the word problem, or whatever comes after the bar, the given tells you whether you are looking at a row or a column. Let me say that again. Whatever the given is tells you whether you're looking at a row or a column. Okay. Female comes second. That's the given. Guys, up here in the chart, where is the word female? Where is it physically located? Okay, right here. It is in a row, guys. So we only care about the numbers in the female row. Okay, we don't care about any other numbers. That's the condition. Assuming that we are only looking at the females. Okay, what are the chances that whatever? Okay, I'm only looking at a row. I will do this in different colors, but I wanted to kind of put these pieces of paper up here so you guys can show you. This is what my brain sees when Mr. Manise does these types of problems. I just tune out everything else. Okay, I would encourage you guys to get some scissors and cut out a couple of pieces of paper tomorrow, especially if you don't have colored pencils. Heck, I'll give it to you. I'll cut out some strips for you so you're focused only on these numbers. Okay, now I'm going to do these in different colors. I'll do the first one in orange. I am only looking at the female row, okay? Out of the females, what are the chances? See that right there? P. That means probability. Let's say how many. What's the probability that they, I guess this is like, okay, that they like fiction novels, okay? Out of the orange row, we've got 0.115 enjoy fiction. Okay, so this is going to be 0.115 out of the total females. The total females is the 0.5. Okay, so if you type that in your calculator, 0.115 divided by 0.5, we get 0.23. Okay, so that's 23%. So basically that's saying 23% of the females enjoy fiction. Okay, all right, let's look at the next one. Probability of male nonfiction. Okay, where is nonfiction physically? This is the given. Write it down. Given. Okay, where is nonfiction physically located? Nonfiction is now in a column, guys. It's in a column. So I only care about the numbers in this vertical column. Okay, nothing else. Out of these nonfiction, how many are males? So let me do this in green. Now I'm looking at this green column. Okay. All right, so we've got a total of 0.25. The given always goes on the bottom, guys, always. 0.25 on the bottom. Of the nonfiction, how many are male? Okay, there's my male. Again, I'm only looking at the green column. There are my males, so I got 0.175. 0.175 out of the total 0.25 nonfiction readers, okay, or ones that enjoy that. Okay, 0.175 divided by 0.25 is 0.7. 70%. I guess I should put boxes around these, huh? Okay. All right, next one. What is the probability that we are female under the condition, under the assumption, given that they don't like romance? Okay, now this is a little bit tricky. All right, or first of all, where is romance physically located? Okay, romance is physically located in a column. So normally I would say I'm only looking at the romance. However, what does this say? This says not romance. Okay, so this is like the reverse. So basically what I'm doing, I don't care about the romance. I want the non-romance. So I'm going to X that out, and I also don't need the totals. Okay. So basically this is what we're saying is the not romance, we're saying we only care about fiction and we only care about nonfiction. We don't care about romance. We want everything but that. And I don't care about the totals. Okay. So basically what we're saying, the given is the nonfiction and the fiction, the non-romance stuff. Okay, so how do I come up? Let me do these. I'll do this in, I guess I'll do this in black. So now for this problem, I'm only looking at the black fiction and I'm only looking at the black nonfiction. I'm only looking at those two columns. Okay. All right. So the total, what is the total? The total, guys, is the sum of both of these. I got 0.25 nonfiction readers and 0.315 fiction readers. I got to add those together. So 0.315 plus the 0.25, that's the total, which is this number, 0.565. Okay. Once again, the non-romance is my given. That goes on the bottom. That's this number right here, 0.565. That goes on the bottom. Okay. And then out of those, how many are female? Okay. Now we've got to add up the females in both columns. We've got to add the 0.115 and the 0.075. If my camera will come back to us. Okay. I've got to add both of these numbers. That's all the females. 0.115 plus 0.075. Those are all of the females that are non-romance readers. Okay, so I got to put this number on top, 0.19, and type that into my calculator. That gives me that number times 100%. That gives me 33.6%. That was a little tricky, guys. A little tricky. Pause the video, rewind it if you need to listen to that one more time. Okay. But I'll tell you, A and B are more likely what you're going to see on the test. Okay. All right, D. What is the probability? Okay, so I still have P, probability, that someone who enjoys fiction novels is a male. Okay, do you see the word given? No, there is no given here. The given is in here, guys. For those of you who have me as a teacher, we bang this dead horse. We beat it to death. So the word who, guys, that's the same thing as given. If I were to replace the word who with the word given, it would pretty much essentially read the same way. What is the probability that someone, given that they enjoy fiction novels, is a male? Okay, so it's almost like we don't need the word who. Okay, so given that they enjoy fiction. Okay, so given, that tells me whether I'm looking at a row or column. Where is the word fiction located? Okay, fiction is located in a column. I'm going to do this one in red. Okay, so once again, we're only looking at this. We're only looking at a column, the fiction column. I'll do this in red for this problem. Okay, out of the fiction readers, okay, that's the given. All right, so that goes on the bottom. Okay, so the fiction total goes on the bottom, 0.315. Out of these people, how many are a male? Okay, we're only looking at these numbers. 0.2 are males. Okay, 0.2. Type that in my calculator, times 100%, and that comes out to be 63.5%. If this were the notation, this would be P parentheses male under the condition, sorry, y'all can't see that, 63.5. Probability this is a male under the condition that they enjoy fiction. Okay, the fiction is the given. What comes after the word given? What comes after the word who? All right, E. If 580 students were given the survey, how many, guys, how many? That's not probability. That's a hard physical number. How many chose nonfiction as their genre? Okay, how many out of 580 students? Okay, well, what's the probability that they enjoy nonfiction? Okay, that's 25. That's 25%, right? So if 580 took it, then it doesn't make sense that we say, well, a fourth of them like nonfiction, so I would just take a fourth of 580, or 0.25 times 580. Type that into my calculator, and that comes out to be 145 students. Not probability, this is a hard number, 145 students. Okay. Number 9, you have a drawer with 4 pairs of Nike shorts, 3 pairs of Adidas, 2 Under Armour, and 4 BCG shorts. You grab a pair in a hurry on your way out the door. What's the probability that you pick Nike or BCG. Okay, when I see the word or, I'm going to add and possibly subtract out any overlap. Okay, so what are the chances that I pick a Nike? Okay, I'm only picking one thing. It's either this or this. The chances of picking a Nike is 4 Nikes out of 4 plus 3, 7, 9, 13. There's 13 total pairs of shorts. 4 of those are Nike. So 4 out of 13. I see the word or, so I'm going to add BCG. I also have 4 out of 13. Okay. Now, is there any overlap? When I pull that one pair of shorts out of my drawer, can it be Nike and BCG at the same time? No. So this is exclusive. Okay. There's nothing to subtract out. So I just add them together and I get 8 out of 13. Okay. Number 10, if you randomly pick a card from a deck, replace it. So I'm already thinking and. I already know the word and is in there because it's replace without replace. What is the probability of picking a black card, then the King of Hearts? Well, there's the word and. It's in there. What is the probability of picking a black card and then picking the King of Hearts? Okay. All right, so what's the probability of picking a black card? Well, half the deck is red and half the deck is black. So the chance of picking a black card is 26 out of 52. Yes, you could write down 1/2, but I'm going to leave the denominator as 52. That's just a good habit because when you're adding fractions, it's easier to add with common denominators. In this case, we're multiplying, so it doesn't matter. But I got half the deck is black, 26 out of 52, times what are the chances of pulling the King of Hearts? There's only one King of Hearts. So I'm going to multiply those together, and it says replace it, guys. Replace it. So when I put that card back, when I put that black card back, I still have 52 cards in the deck. If it said does not replace, then this would change to a 51. Okay. So I'll multiply these together on my calculator, press math fraction, and this comes out to be 1 out of 104. Okay, home stretch here, guys. Home stretch. Let's see here. Oh, not the home stretch. We still got some more to go. Guys, I'm going to have to break this up into 2 videos again, probably. Okay. So number 11 here, a 6-sided number cube is rolled. When it says a standard number cube, guys, that's just a die, just something 1 through 6. A 6-sided number cube was rolled 65 times. The results are shown in the table. Answer the following questions regarding experimental versus the theoretical. Okay, remember theoretical, theory, that's what's supposed to happen. Experimental is based on the data in the chart. What is the theoretical? Okay, when I see the word theoretical, don't look at the table. I don't care about the numbers. What is supposed to happen when I roll a die? What are the chances that it lands on a 5? Okay, that's just 1 out of 6. Nothing to think about there. There's a 1 out of 6 chance that you roll a die and it's going to land on the number 5. Okay, number 2, or B says, what is the experimental probability of rolling a 5? Now we have to look at the data. They rolled 65 times. They got a bunch of different answers. How many times did it land on 5? It landed on 5. It landed on it 9 times out of the 65 times in the experiment. So that's 9 out of 65. If you're not sure if that reduces, type it in your calculator. 9 out of 65, math, boom, boom. Well, it obviously doesn't simplify because it's the same thing. Okay, theory. What's supposed to happen? What are the chances of rolling an even number? Well, it can be a 2, it can be a 4, it can be a 6. Okay, 3 out of 6 numbers are even. That's 1 out of 2. 50% chance of rolling an even number. What is experimental? Now we're back to the chart. What is the experimental probability of rolling an even number? Okay, I'll do this in green. Well, 2 is even, 4 is even, 6 is even. They got this even number 8 times, they got the 4 10 times, and they got the 6 11 times. So I got to add those up. 8 plus 10 is 18, plus 11 is 29. Okay, so that's going to be 29 times they got an even number out of the 65 total times in the trial and experiment. 29 out of 65. Okay. Number 12, on the last test of the 26 students who passed the test, 19 of them studied. Of those who failed the test, only 1 studied. There were 31 students who took the test. Create a two-way frequency table for the given information and then answer the questions below. Okay, so we're going to have to, you're not going to have to create this on the test tomorrow, but this is a good exercise for us to do this. Okay, and it actually doesn't matter, guys, whether I put the studied, not studied over here and the past, not passed up here. You'll get the same answer. I'm going to choose to put the study, no study on the side. So I've got studied, I got not studied, and I've got the total. And then I'm going to have up here, I'm going to have passed, and then I'm going to have failed, and then I'm going to have the total. So my chart is going to look like this. Okay, so we got to look at the data. 26 students passed. Okay, so 26 here. 19 of them studied. Actually, I'll draw a line up here too. Okay, 19 of the 26 that passed, 19 studied. Of those who failed, only 1 studied. So 1 goes there. There were 31 students who took the test. So now I should be able to fill in the rest of the chart. 19 plus 1 is 20. 26 minus 19 is 7. 31 minus 26 is 5. And then 5 minus 1 is 4. 7 plus 4 is 11. Okay. 20 plus 11 is 31. Check. 26 plus 5 is 31. Check. Check your numbers. Okay. All right. Based on this data, we're going to answer some questions. Did more students choose to study or not study for the test? Okay. This is not a probability. This is a hard number. Okay. So how many students studied? 20 studied. Who did not study? Only 11 didn't. Okay, so more students chose to study. 20 is greater than 11. What is the probability? Now we got decimals, fractions, percentages. What's the probability that a student who studied? Okay, who studied? Remember, that's the given. I can cross out who and write the word given. Given that they studied. Where is the word studied, guys? Where is it physically located? It is in a row. So we are only looking at the numbers in that row. We're only caring about the people who studied. Out of these 20 people who studied, who passed the test? 19 out of 20. Okay, so this would be like probability of passed given that they studied. And that's going to be equal to 19 out of 20. Tomorrow on the test, and maybe it's a percentage. That would be 95%. That makes sense. 95% of students who studied passed the test. If you guys are watching this video, then you're studying. So I'm hoping you're going to pass the test. Okay, C. What is the probability that a student who passed, given that they passed, studied? Okay, where's the word passed? Passed is in a column. So now we're only caring about this column. Of the 26 who passed, okay, those who passed, how many studied? Okay, 19 of them studied. Okay, so this would be probability of studied under the condition that they passed. Okay, and that's going to be the 19 out of the 26 number. And that comes out to be 19 divided by 26. That comes out to be 73.1%. Or we can just round that to 73% this time. That's fine. Okay. Sorry, I know it's kind of hard for y'all to see all this at once. What is the probability that a student in class both studied and passed the test? There's no condition here. There's no given. There's no who. There's no word given. I want to know how many both studied and passed. Okay, so this would be like the intersection. This would be the intersection of studied and passed. Okay, all right, so the probability is going to be 19 of those out of the total of 31 students. 19 over 31. Okay, there's no condition, there's no given there. 19 out of 31. All right, are the probabilities of studying and passing the test independent? Show the work. Okay, so here's where you got to do. This is like your A. That's your probability of A. The passing is your probability of B, and then you got to figure out, does the probability A times the probability of B, does that equal the probability of A and B? Okay, so what's the probability that someone studied? It says show your work. I'm gonna do this down here. All right, so the probability that someone studied is going to be 20 out of 31. So probability of study is 20 out of 31. Then I got to find the probability that they passed. Okay, the probability that they passed is going to be 26 out of 31. So probability of passed is 26 out of 31. Okay. Now, when I multiply those together, the probability of A times the probability of B, does that equal the probability of A and B? So what's the probability that they studied and passed? Well, that's still going to be these 19 out of 31 people. So does that equal 19 out of 31? Okay. So if I plug this in my calculator, 20, make sure y'all can see this, 20 over 31 times 26 over 31, that gives me that number. 19 over 31 gives me that number. Okay, they do not match. I'm going to say 0.054 is not equal to 0.61. Okay, so when they don't equal each other, the answer is no. They are dependent. Okay, dependent, they don't match. If the left side equals the right side, then they are independent. Okay. All right, let me do this last one here, F, and then I will do the last page in a separate video, part 2. Okay, what is the probability of a student who failed the test, did not study? Okay, probability who, there's your given. Okay, given that they failed. Where's the word failed? It's in a column. Okay, so we're only looking at the people who failed. Out of those people, okay, who did not study? Okay, we have 4 people did not study. Okay, so that's going to be the total people that failed is 5. That's the given. And then out of those 5 people, 4 did not study. That's 80%. Okay. Okay. All right. So that's it for this. That's it for this video, guys. For part 1, and I'll pick it up here on part 2. We'll see you on the next one.